Okay, 7.6, we're going to be solving exponential and logarithmic equations. So we're taking what we know with 7.5 and applying it to solve. Okay, so the first part we're going to have logarithmic. Actually, no. The first part we're going to do exponential, and then the second part we're doing logarithmic. Okay, so with exponential, your goal is always to try and get like basis. Okay, if you can't do that, then what you need to do is isolate whatever is being raised to the exponent with your x, and then you're going to take the log or natural log of both sides. Okay, so if I'm looking at 6 to the x equals 42, I cannot manipulate 42 to have a base of 6. Yes, 6 times 7 gives me 42, but that's not what I'm doing. I'm doing 6 raised to an exponent to get me 42, which would never work. Okay, so what I'm going to do is I'm going to take the log of both sides, so log 6 to the x equals log 42. And then I'm going to use my properties. So I have an outer exponent. What do I do with that outer exponent? I move it to the front. So x times log of 6 equals log of 42. Now if I want x by itself, what am I going to do? Divide by log of 6. Now, I want you to understand that log of 42 divided by log of 6 is not log of 7. Okay? So, you can't just take the numbers and divide those. What you're going to do is actually type your log of 42 divided by log of 6 in your calculator, and you're going to get a decimal. And let's say we round it to 4 places behind the decimal. If I don't specify, just do 4. Okay, so I've got my fraction, and I'm going to do log of 42 divided by log of 6. And so that's going to give me 2 point what? Alright, so 4 places behind the decimal, 2.0860. Simple. Okay. So if I have 6 to the 3x plus 1 equals 8, I can't get 6 and 8 to the same base. So I'm going to take a log of both sides. Alright, and what am I going to do with that exponent? I'm going to bring it forward. So that is in parentheses 3x plus 1 times log of 6 equals log of 8. Alright, at this point, there's 2 things you could do. You could take this log of 6 and distribute it, and then subtract and divide. I'm not going to do that. I'm going to go ahead and I'm going to get that log of 6 on the other side. So I'm going to have 3x plus 1 equals, and I'm going to go ahead and evaluate what that is. Okay? So, log of 8 over log of 6, 1.160 what? 6. So I'm going to use that, subtract my 1, so 3x equals 0.1606. Then divide by 3. And you get 0.0535. Are we good with that? Okay. Now this next one, I've got 8 to the 2x minus 5 power and 5 to the x plus 1 power, and those are equal. So when I take the log of both sides, I now have to take both exponents and move them forward. Okay, so 2x minus 5 times log of 8 equals x plus 1 times log of 5. Now this time, I can't just get rid of my 8 because I have an x on the left and an x on the right. So I have no choice but to distribute these logs so that I can eventually get my x's on one side. Okay, so that's going to be 2x times log of 8 minus 5 times log of 8 equals x times log of 5 plus 1 log of 5. Okay, all I did was distribute that log and it picked up everything in parentheses as its coefficient, yes? Okay. Now, I need my x's on one side, everything else on the other. So that means I'm going to take this x log of 5 and I'm going to subtract it to move it to the left, and I'm going to take this negative 5 log of 8 and I'm going to add it to move it to the right. Okay, so I'm going to have 2x log of 8 minus x log of 5 equals my log of 5 plus 5 log of 8. Okay. Now, I've got an x in this and an x in this, but they're not the same log, so I can't combine them. What can I do? I can take out this x as a GCF, right? I can factor it out, and that leaves me with 2 log of 8 minus log of 5 equal to my log of 5 plus 5 log of 8. Y'all follow me? So then how do I get x by itself? Divide by 2 log of 8 minus log of 5. So type that in your calculator and see what you get. What'd y'all get? Mm-hmm. 7095. Okay, do we have questions on how to do that? Okay. So then this next one, I have the fourth root of 3 to the 4x plus 5 equals 7 to the x power. What does the fourth root really tell me I'm doing? If I wanted to rewrite that, I could take 3 to the 4x plus 5 power raised to what power? 1/4, right? Equals 7 to the x. Now there's two things I could do here. You could choose to distribute that 1/4 to the 4x plus 5 because an exponent raised to another exponent you multiply. Or, what else could I do? Raise it all to the reciprocal power, which would be 4. That will leave me with just 3 to the 4x plus 5 equals 7 to the 4x. To me, I'd rather do that. Okay? Get rid of that fraction. But you have to know that that radical means you can put it as that fraction, that rational exponent. So now I can do my log of 3 to the 4x plus 5 equals log of 7 to the 4x. And then what am I going to do? Bring my exponents forward. So 4x plus 5 in parentheses times log of 3 equals 4x log of 7. What am I going to need to do next? I'm going to have to distribute because I have an x on the left and an x on the right. So 4x log of 3 plus 5 log of 3 equals 4x log of 7. Now I want my x's on one side. I would just move this one over here. So I've got my 5 log of 3 equals my 4x log of 7 minus my 4x log of 3. Now, does that become log of 4? No. Just because they look similar doesn't mean that you can do that. Okay? Now I'm going to factor out an x. That leaves me with 4 log of 7. Because you're going to end up dividing by 4 again. So I just want the x by itself. And then 4 log of 3. If you do the 4x because you see it, that's fine. Just know you'll divide twice. So now we divide. I'm running out of room, but we divide both sides. I'm going to bring it up here. X is equal to 5 log of 3 divided by my 4 log 7 minus 4 log 3. And see what you get in your calculator. What do you get? Very good. Y'all understand what I'm doing? So then my next one, I've got 4 times e to the negative 0.3x power minus 7 equals 13. What am I going to do? Not yet. But I will. How do you know I'm going to eventually take the natural log? The e. I need to isolate what's being raised to the exponent. So I'm going to add my 7. So 4 times e to the negative 0.3x equals 20. And then divide by 4. E to the negative 0.3x equals 5. Now I'm going to take the natural log of both sides. It has an e, so I know I take the natural log. And then what do I do? I have an exponent that needs to come forward. So negative 0.3x natural log of e equals natural log of 5. What do I know about the natural log of e? It's 1. So I just have negative 0.3x equals natural log of 5. So what do I do? I've got natural log of 5 divided by negative 0.3. So remember, to get your natural log, you do your log but go to the right. Natural log of 5 divided by negative 0.3. You're going to get negative 5.3648. Okay, walk me through my next one. So I've got 7 to the 5x minus 1 power equals, and then log of both sides. Huh? You could, but you'd be wasting some effort. What happens when I take log of a negative 7? I can't, because I can't take the log of a negative, so this is just no solution. Because of this right here. If you need to make a note, if you go back to your notes and you wonder why it's no solution, it's because of that negative 7. Okay, we good with exponential equations? Okay, solving logarithmic equations. So again, you can't take the log of 0 or a negative, so when you start with log, you're going to have to go back and check that. Okay, we're going to use our properties of logs from 7.5 to do everything we can. And then some cases we're going to be able to do our one-to-one property. Some cases we're going to have to move it to exponential form. Okay, so see how we started with exponential, we had to go to logs. Now if you start with logs, you might have to go to exponential. Okay, so here I have 2 times log base 3 of 6 minus 1/4 times log base 3 of 16 equals log base 3 of x. So properties of logs. I have 2 logs on the same side. I'm going to condense that. Okay, just like we did in 7.5. So this 2 becomes the exponent for 6, and this 1/4 becomes the exponent for 16. Okay, so that becomes log base 3 of 6 squared minus log base 3 of 16 to the 1/4 equals my log base 3 of x. Now, what does a minus mean? I'm dividing, so I'm going to have a fraction. So I'm going to have log base 3 with a fraction. 6 squared is what? 36. Now, 16 to the 1/4 is the 4th root of 16. And I'm going to write that, then convert it. Okay? Now, the 4th root of 16, he's saying is 2. Technically is plus or minus 2, but at this point you don't have to do the minus. Why? Because you can't take the log of a negative. So this is just 2. So 36 divided by 2 is what? 18. So log base 3 of 18 is equal to log base 3 of x. X equals to 18 because I've got my one-to-one property. Now, I went ahead and boxed it because I knew I was just taking the log of x, which it's positive, so I'm good. Okay, but don't forget to plug it back in to x and make sure you're not taking the log of 0 or a negative. Okay, so this next one, I've got log of z plus log of z plus 3 equals 1. What am I doing there? Multiplying because it's a plus. My properties tell me if I see a plus, I'm going to multiply. So I've got log of z times z plus 3 equals 1. What's z times z plus 3? Okay? Now, when I only have one log on one side, this is whenever I'm going to put it in exponential form. Okay, so remember it's log base solution equals exponent. Okay, what's my base? It's not written. It's 10. So my base is 10, my exponent is 1, and my solution is my z squared plus 3z. What do you think I need to do? I need to subtract to get it equal to 0 and factor. Okay, so that's going to give me z squared plus 3z minus 10 equals 0. Factors of 10 to give me 3 would be 5 and negative 2. So z plus 5 equals 0. Z minus 2 equals 0. So z equals negative 5 and z equals 2. Negative 5 does not work because if I plug that in here, I'd be taking the log of a negative. But 2 works, so negative 5 is extraneous, so just mark through it. Okay? The next example, I have no extra work to do. How do I solve that? E to the 6 equals x. Put in exponential form. Natural log has a base of e. Log base solution equals exponent. E to the 6 equals x. So, in your calculator, go to natural log, go down to e to the 6. So x equals 403 point. Oh, it says 3 places. My bad. I don't know how to read my own instructions. Alright, it's just 403.429.
So which one has the like under in the row?
When you see log with no base, that's your common log. That has your base of 10. Okay. Alright, next one. What am I going to do? Those become exponents. So I've got log base 3 of y equals log. Now, 16 to the 1/4 is really 4th root of 16 plus log, oh, I've got a log base 3 there. My bad. It's not typed, but it should be there. And then 64 to the 1/3 is the cube root of 64. So log base 3 of y is equal to log base 3 of, what's the 4th root of 16? What is the cube root of 64? What am I doing with a plus? I'm multiplying 2 times 4. So log base 3 of y equals log base 3 of 8. So y equals 8. What do I do for my next one? Subtract the 4, so natural log of 2 minus 3x equals 3. Very good. Now, I'm not going to evaluate e to the 3rd just yet. I'm going to go ahead and just solve for x and then plug it in my calculator. Okay, so I would subtract my 2, negative 3x equals e to the 3rd minus 2. divide by -3. So, I've got e to the third minus 2 over -3. Be 9 since we've got it rounded to 3 decimal places. Y'all have questions? Okay, so your next class, you will have a quiz over 7.5 and 7.6 combined. Okay?